And welcome back, and it is the 6th of March, 5 a day for further maths. And let's just jump straight into the first question. Oh my God, what do we have here? Okay, this looks horrible. Now it is simplify. So the word simplify tends to mean that something should happen, and I'm going to get a lot of cancelling. Actually, I've just realised that's a plus there, isn't it? And this is a divide here. So actually, and I presume it wants me to do this, there's no reason to think not. I need to think of BIDMAS or BODMAS or PEDMAS or whatever it is you may have learned, which is actually, there's really a secret pair of brackets here, isn't there? Because I need to divide before I add. Okay, so let's do that first. So let's write this down. So I'm going to keep the x minus 1, x plus 1 there, so I don't forget to do it. Then I'm going to add, and I'm going to do the thing inside the bracket. So it's going to be x plus 4 divided by x to the power of 4. Keep change flip, so multiply by x over. Now, remember what I said, I'm expecting something to cancel, and actually 4x plus 16 does factorise down to 4x plus 4, which is good because that's going to cancel with the 4x plus 4 over here. In other words, that's going to cancel, iPad moving, sorry, and that's going to cancel as well. And I can also see the x and the x4 cancel down slightly, but let's come back to that in a second. So then if I write it up again over here, so I've got x minus 1 over x plus 1, and then I'm adding on x over x to the 4, which is the same basically as x, it's not x, sorry, the x is cancelled, as the same as 1 over x to the 3, which is looking significantly better than it was. What now? Oh, I've forgotten a 4 as well, haven't I? So it's 4x to the 3. The next step is common denominators. So what I'm then going to do is make the common denominator 4x3. I'm hoping we're going to get another step of simplification. So 4x3 times x plus 1 is going to be my denominator. I'm going to multiply the left fraction by 4x cubed. So that's going to give me 4x cubed x minus 1. And then I'm going to add on one lot of x plus 1. Wow, this doesn't look brilliant, does it, so far? Okay, let's expand and see what happens. I'm basically hoping that more stuff's going to cancel, but it doesn't hugely look like it right now. Okay, so let's expand it. So that's giving me 4x to the power of 4 minus 4x to the power of 3 plus x plus 1. And all of that is divided by 4. Actually, I won't write brackets there. I'm just going to write it in one go. So that's 4x cubed, x plus 1. And I don't think I can do anything else. I think that's it. Normally these questions really do simplify down much better than that, but I'm pretty sure I'm done. I'm going to stop there. I'm going to call it there. I'm locking my answer in. I will obviously check it before I load the video up, just to check I'm not doing anything remarkably stupid, but I think that's it. If I was in an exam, what I would do is I would put the number 1 into here and put the number 1 into here, and then just see if I get the same answer. So if I've got time, I would do that as well. Anyway, we spent enough time on that. Next question. Use Pascal's triangle to work out the coefficient of x cubed in the expansion of. So it's the power of 4. Now, again, you may not know your Pascal's triangle off by heart like I do. So you might have to write down 1, 1, 2, 1, 1, 3, 3, 1, etc. But either way, your fourth line will look like this. Then what you'll do in the expanding, so this is going to be x to the 0, this is going to be x to the 1, this is x squared, this is x cubed, and this is x to the power of 4. And I want x cubed. So in other words, I want this one here. So therefore, my expansion of that particular term is going to be 4, which is the combinations bit, times by 1 to the power of, well, I want x cubed, and this is a 4, and 4 minus 3 is 1. So in other words, it's going to be 1 to the power of 1. Obviously, I don't need to write 1 to the power of 1, but just so you know what I'm doing. And I'm going to multiply that by 3 times x to the power of 3. And then let's just tidy this up. So that's going to be 4 times 27 x cubed. And 4 times 27 is going to be 108 x cubed. And then read the question. Use Pascal's triangle to work out the coefficient. Now the coefficient is the number, not with the x cubed. So the answer to my question is 108. And that is the next question done. Next question. All right, so we have, I'm just reading down, see if the questions are connected, but they're not. So the next question is just your basic differentiation, isn't it? So I've got y equals 2x to the power of 4 minus x to the minus 1. Differentiate once is going to give me dy dx equals 8x to the power of 3. Minus minus is a plus, and then take away 1 is minus 2. And then differentiate again, so d2y dx squared is going to be 24x squared minus 2x to the minus 3. And then what does it want me to do? It wants me to actually put a value in. So at x equals minus 2, d2y dx squared is going to be equal to 24 minus 2 squared minus 2 times minus 2 to the minus 3, which is going to be eighths. So I'm going to get my calculator out, and that gives me a final answer of 96.25. Question done. Okay, next and final question today. F of x equals something with a domain all values of x. In other words, I can put in every value into this function. Work out the possible values of c. Oh, okay, this is a nice sort of back to front question, isn't it? Because it's telling me this will work for all values of c. Now, the only way that will work is if I'm not square rooting a negative number. So therefore, it must be the case that my graph sits on or above the x-axis. And so therefore, the critical value there is going to be if my determinant, b squared minus 4ac, is equal to 0. So b is 8, so 8 squared, minus 4 times the a, which is 1, minus, or times minus c, so that's going to be c, and I'm going to change this to a plus. And I want that to equal to 0. So I've got 64 plus 4c equals 0, which means that c equals minus 64 divided by 4, which is going to be minus 16. So let's think through carefully what I've got here. So I can't let c be any value greater than minus 16, because I'll be taking away too much, which means therefore I'll get a negative number. So therefore it must be the case that c is less than or equal to minus 16. Question done. Quite a difficult question, that last one, actually. That was phrased really well. As ever, let me know how you did. I thought it was a nice little mix of questions today. Not too bad at all. That first algebra question, probably a little disappointing, because I would have hoped that would really simplify down better. And as I said before, if you're watching this, it means I have double checked it, so it's okay. And the last one, really clever little twist on a domain question. As I say, let me know how you did. Do like and subscribe, and I'll see you for tomorrow's. Thanks all.